All right, Honor Stats. We are now dealing with the last section of chapter 7, which is 7.6. And it deals with normal approximation to a binomial distribution. And you guys should know when you hear binomial distribution, they're going to be giving us a P, which is a success, a Q, which is 1 minus P, which is the failure, and obviously an N. And we're also going to do it with a P hat distribution. Okay, so there'll be a few little formulas that you're going to need to know in this section. Alrighty. All right, we talked about this yesterday, so let's talk about our assumptions. What two assumptions need to be done before you can start any one of these problems? And I'll give you the first. N times P must be what? Greater than 5. And then also N times Q must be greater than 5. You must do that first. If you do that and one of those comes out to be a number less than 5, or I should say 5 or less, you can stop right there and say, this binomial distribution is not normal, and move on to the next question. So these two criteria have to be met. And just think about it. 2 seconds ago, you're going to have a P, a Q, and an N. So that's the first thing you want to do. The second thing you're going to do is you're going to compute the mean and our standard deviation. Does anybody remember the formula for mean? It's just, no. It's N times P. So it's actually N times P, which you've already done it here, if you think about it. And what is our sigma? The square root of N times P times Q. Okay? So once you prove the two assumptions, then you can find the mean and standard deviation of your population. Now, our continuity correction. In my other class, I did it wrong. I did 2 of them wrong. All right? I taught myself how to do it, so hopefully I'm going to have everyone watch this video and I'll tell my class tomorrow what I did. Okay, first of all, let's do the one that we know, the one that was yesterday. So we have a probability. I'm going to make these two numbers up. I'm going to make up 15, and then our R, and let's make up 17. So we have the probability that our R is in between 15 and 17. Well, we do not have the ability to turn an R into a standard value, a z-score. We can only do that to x. So our continuity correction says that if you are going to change this to x, then you have a little bit of space to go. For the 15, you're going to go less than 0.5, so subtract 0.5 and go to 14.5. And on the R is less than 17, the right point, you are going to go add 0.5 and get 17.5. Okay. Now, what gives this to us, guys? You have to look at this right here. Well, let me go back up to this. This in terms of the R, and let's go this, and this in terms of the R. So if you're reading that 15, you have to read it, R is greater than or equal to 15. If you're reading the 17, you have to read it as what? R is less than 17. So we know that we have 2 other problems in these sections. One of them is this. What if it's the probability that R is less than or equal to 17? Guys, it's just like this right here. Do you actually see R is less than 17 sitting there? So therefore, if we were going to change it, you do what? Add the 0.5, 17.5. Phenomenal. But now, here's the one that I messed up. Well, I messed up on both of these. But the probability that R is greater than or equal to 17. The book did something really nice to me. They actually wrote this differently. They wrote this with the 17. Notice it points to the 17 and the R is here. So it looks like this part, doesn't it? So actually this one is going to be what? The probability of 16.5 and X. Okay. I want you have to look at over here. Okay. That's why you took away. So let me say this again. So for this one right here, when you have, let me go to my highlighter, when you have a less than problem and you're doing the continuity correction to a less than, you add 0.5 to the R to make it the X. I'll do this one in green. When you have a greater than, if you want to rewrite it this way, but it's still greater than, R is greater than, you subtract the 0.5. So it's almost like an opposite memorization. Less than problems, you add 0.5. Greater than problems, you subtract 0.5. Commit that to memory, please. And then everybody, if you look at this guy over here, this one here, convert the X values to a range of standardized Z-scores. Remember, once this is an X form, once it's an X form, then you can convert it to Z by doing the X minus mu divided by sigma. That'll give us our Z-scores for each of them. And then you look up on the chart and get our probabilities. And the 6 that we're doing in this chapter, in this section, is we're going to be dealing with a sampling distribution for p hat. Now for p hat, it's a little bit different. Our mu of p hat is going to be whatever we had for p. And our standard deviation of p hat is a new formula, p times q divided by n, take the square root. And that's when you have a sample. Okay, and we'll look at that in the last example of the day. Okay? Okay, here comes our first example of a binomial distribution. The probability that a new vaccine will protect adults from cholera is known to be 0.85. The vaccine is administered to 300 adults who must enter an area where the disease is prevalent. So, just in that opening paragraph, we know what P is. That's our success, 0.85. We know what Q is, 1 minus 0.85, which is 0.15. And we know that N, there are 300 adults in this vaccine trial administration thing. Our question will hold the R. Okay, the R is your sample. All right, what's desired? What is the probability that more than 280 of these adults will be protected from cholera by the vaccine? Now, this book doesn't go any further. They actually stop this problem, but we're going to do this problem in its entirety. Okay? So there's the pieces of information. So the first thing I want you guys to do is what? What's the first thing we need to do? Make sure it's normal. Phenomenal. So you must come over here, and I want everyone to know that you have to prove that n times p is greater than 5 and n times q is greater than 5. Okay, so this is the teaching. What do I want to see? please watch. You should write NP, put an equal sign. N, everybody, is 300. P is 0.85. You pull out your calculator and you go 300 times 0.85, and you're going to write down 255. Below it, you're going to write NQ is equal to 300 times the 0.15. 300 times 0.15 yields a 45. And here's the part that you must write. You're going to put this little symbol here that puts them together, and you are going to write the words, both are greater than 5. So you're going to show them to me. You're not going to write down 255 and 45. You're going to show me that NP is 300 times 0.85 and give me the number. NQ is 300 times 0.15, give me the number. And then you must have the words, both are greater than 5. At that particular point, you now know that this binomial distribution is normal. Once it's normal, what are you going to find? Mu. Not mu of p hat, because this is not a sample. Okay, you're going to find mu. Mu is what? N times P, 255. You're going to find sigma, which is the square root of 300 times 0.85 times 0.15. Squiggle, squiggle. Second square root, 300 times 0.85 times 0.15. Enter. 6.18. 6.18. Now we're going to write our question. We want to know this R, which is 280. We want to know the probability the R is greater than or equal to 280. Actually, it just says more than, so I won't worry about the equal to. Okay. So we must do our continuity correction. When we change an R to an X, what did I tell you about greater than? You subtract 279.5. Now we have to convert to a Z. Ladies and gentlemen, let's convert to a Z. So 279.5, take away the 255, divided by 6.18. So 279.5, take away 255, divided by 6.18. It yields 3.96. 3.96. I've yet to do this on a video, so I'm going to do it on a video for you guys. Our chart officially goes up to negative 3.89 and positive 3.89. I'll do this in red for y'all. It looks to me like 3.96 is over here. 3.96. If you look at greater than, that means look over here and tell me what you see. You see nothing. That means the answer is 0. If this was a less than problem, what do you see to the left of it? I see everything. I see the entire curve. That means 1. You guys got to get that. Now, the probability of this occurring is 0. And let me kind of explain. If there's 280 and I divide it by 300, that's 93.3%. 93.3%. Well, the going rate is 85. That's a lot larger than 85. So they're trying to say, if they only take a sample of 300 people, normally 85% are protected. And for some reason, this weird, mysterious reason, 93% of the people and more were protected. Something's wrong. You see what I'm saying? That's why the probability is what? 0. Okay. So this, ladies and gentlemen, is an example of a binomial distribution and finding the probability of it. Point. So again, just to make sure you know all the pieces in play. N, number of trials, that was our 300. R, the number of successes. The R is usually found in the question of the problem. They want to know more than 280. The 280 is your R. The P is the probability of success. In that last example is 0.85. And Q is 1 minus R, 0.15. Here's your NP, NQ greater than 5. And then notice that we did use our mu, which was N times P. We got 255. And our sigma, the square root of NPQ, which we got was the 6.18. Okay? And the one thing, everyone, as N does get larger and larger and larger, your approximation becomes better. And that's what I want to show you here. I'm going to keep the video going. Right now, N is 3. Then I'm going to go to 10, 25, and 50. If you look at the histogram, when there's only 3 things being chosen, it doesn't look very symmetrical. So when you move on to 10, it gets a little more symmetrical. 25, much more symmetrical. And 50, really symmetrical. And when it's really symmetrical, they basically tell you that it's very normal. Okay? So, in so many words, the larger the N, the more normal the distribution becomes. Here's our procedure for the continuity correction. The left point, we subtract 5. Remember, it's when it's greater than, right? Greater than, you subtract 5. On the right point is less than you add 0.5. And they showed you the in-between. So if you look at this very closely, let me pinch it open really big here. Let me get rid of what I just highlighted. Nope. Let me erase it. And there it goes. Okay. So with that said, please look. R is greater than 6. See, if you read it the correct way, you read it this way. R, this is a greater than symbol. You subtract 0.5. R is less than 10. See, less than, you add 0.5. Okay? Now let's take a look at a sampling distribution for our proportion p hat. So they're going to give you, in the opening statement, a p, which we know we can find a q from it. But then they're going to go on and say a sample from that was taken. As soon as you see that secondary problem, a sample was taken, then we're dealing with a p hat. P hat, everybody, is R divided by N, but that's in your sample itself. So N is the number of trials, R is the number of successes, P is the probability of our success, and Q is the failure. Notice our 2 criteria have to be met in order for it to become normal, i.e. standardizing it. But now everybody is a little bit different. Our mean of our p hat distribution is simply going to be what p is. And our standard deviation sub p hat has a new formula, the square root of p times q divided by n. And the book didn't go into detail and finish this problem. They didn't even give us a question, okay? I'll see if I can come up with a question and continue it. So here we go. The annual crime rate in a Capitol Hill neighborhood, so we got this big old neighborhood. of Denver is there's 111 victims per 1,000 residents. So guys, they gave us our P without giving us a decimal. They said 111 out of 1,000. You'll see in a moment, but we as a class will talk what we're going to do. 0.111. That means our Q is 0.889. Everyone good with P and Q? These crimes range from minor crimes to major crimes. But now here's the subsidiary moment that we'll just do that very question. The Arms is an apartment building in that particular neighborhood. So it's a single apartment building. It's a cluster. If we go back to our sampling techniques, there's 50 residents inside of the Arms. Suppose we view each of them, and this is 50 residents, as a binomial trial. Then our random R, which takes on the values 0 through 50, represent. So notice they didn't give us an R. They didn't give us a question. They could say, what is the probability that 7 of the 50, or at least 7 of the 50, had crimes? Okay? Or less than 7. That's probably what I'm going to do here in a moment. Residents, they went to 3 decimal places. So, if we understand how to find P and Q, which I have already done, that's the first thing you're going to do. The next thing you're going to do is you're going to have to do the NP and the NQ. Notice you get a 5.55 and a 44.45. So you can't find those unless you have the N or the P and the Q, right? So 50 is our sample. Why? Because we're dealing with the Arms, that single place, that single building inside of there. Okay? This is unfortunately what's not given to us. They didn't give us a question. Okay? They did not give us a question. Let's make one up. So, since the pop is about 11%, let's go to 14%. Let's go smaller. Let's go to 10%. So, I'm going to say, what is the probability? What is probability less than 5 of that Arms, the Arms building, had some type of crime? All right, less than 5. Whew. All right, so. Guys, our sigma, our mean is going to be what P is, 0.11. Our sigma is going to be PQ divided by N. Notice they did the work for us, and this is what they got. Now we're going to go a little further. I asked about 5 out of what? 5 out of how many? 50, which is 0.10. Agree? So that means that's my R is less than 0.10. Right? I may not complete this problem. All right, the book didn't do it. I may just hold off here, and we'll do the homework and stuff because I don't want to get into something. All right, but for right now, let's just stop here, knowing that you can find our mean and our standard deviation. Okay. When we do the homework, we'll do problems in its entirety. As you can see, this is the last page of the book is what they did, okay? For some reason, they didn't want to do a problem, so I don't want to make one up just in case. So let's hold off here. But just so you know, everybody, that's how then R will be given in the actual sentence. Okay? So reiteration, we have a binomial distribution and you have a p-hat distribution. The binomial distribution is going to give you a p, a q, an n, and an r. The p-hat is going to give you your p and q, but then it's going to continue on and talk about a sample. That's how you know the difference, okay? All right, so over the next few days, we're going to be working on the homework and